Okay, let's get started. Actually, don't need paper open because we're doing the technology questions. Okay. Okay. Let's see now. 217. The velocity v in centimeters per second of blood in an artery at a distance x from the center of the artery can be modeled by the function as given below. Fx is defined as 500 times 0.04 minus x squared for x between 0 and 2. So what I'm going to do is make this equation, and then I'm going to just run this. Okay, and then I'm going to solve percent O2 for x. Now, we've got two values, basically the plus or the minus, but the x has to be positive, 0 to 0.2. So we're going for the plus one here. So I'll just call the inverse function g because, or I could give it some name like f. Maybe I can call it f inverse. It's defined as, now, is there any way I can get just this? I wonder if it's possible if I type in percent %03. Ooh, oh well, it has the x equals in it. I don't think this will work. I just resort to just a simple copy and paste. Okay. Oh, no. Of course, I'll have to change this to y for that to work properly. Okay, that's better. Now that we have the inverse terms what this inverse function is used for. So that is the opposite to find the position or the distance given the velocity. And then we just have to calculate for 15, 10, find the distance for 15, 10, and 5. So what have I got? 15, 10, and 5. Okay. Now I suspect the answers are going to be numeric. Yeah, so let's get these to numeric, to numeric, to numeric, and to numeric. So 0.1, correct, 0.14, and 0.17. Right, so that's 217 done. Yeah, okay. Now 218. Make sure I'm still recording the sound because my microphone has cut out in the past. 218. Okay. A function that converts dress size in the United States to those in Europe is given by. So a function that converts dress sizes in the United States to those in Europe. So I guess the D is the European size. And we have to calculate then. Find the European dress size that corresponds to size 6, 8, 10, and 12 in the United States. 6, 8, 10, and 12. 6, 8, 10, and 12. I think that's all okay. Yeah, okay, that's good. Find the function that converts European. Yes, so this is the inverse now. Okay, so we'll have what y equals dx that we want to solve percent 06 for x. Then we can make the inverse function, we'll call it e. That's equal to y minus 24 over 2. And then, no doubt, we'll have to use that 46, 52, 62, and 70. Oh, I never put my code on. It didn't compute. There we go. 46, 52, 62, and 70. Okay, that looks okay. Let's continue. Okay, this is now 219. Cost to remove a toxin from a lake is modeled by the function Cp. That's 75p over 85 minus p. Cost in thousands of dollars, and p is the amount of toxin in a small lake, parts per billion. This model is valid only when the amount of toxin is less than 85 parts per billion. Yes, and it can't equal 85 because it would be infinite cost as we approach 85 from the left. So find the cost. Yeah, okay, so just a calculation. Cost 25. Now this, I'm going to multiply this by 1,000, so we'll have the dollar amount because this is in thousands. Cost 40. Cost 50. And then find the inverse function. So again, usual story here. Y equals Cp. Let's run this. Oops. Oh, I keep forgetting to multiply. Okay, and then the inverse function. So that would be getting the level of pollution. So maybe I should call that capital P for the cost. I should use more sensible letters. Oh, not yet. I haven't solved it yet. I haven't solved it yet. Solve percent 05 for key. Okay. And then, what did I call it? This is the pollution from the cost, which I'll call small c. And that's defined as 85 times c over c plus 75. Then, not to be cut out, 50,000. So it's P50, not 50,000. Okay. 34 parts per billion. Let's check the answer. Oh, 31,250. But the next one, I should make that numeric. Yep. 2 decimal places since it's money. The next one, I'll make that numeric as well. Yep, that's right. My inverse function is right. And 34 parts per billion. Okay. Another one done. Okay. 220. A race car is accelerating at a velocity given by Vt is defined as 25/4 times t plus 54 feet per second. Find the velocity of the car at 10 seconds. Okay, find the inverse function. So let's give it a different letter than y all the time. Let's call it t. Yeah, no, okay, I'll call it y. But maybe I'll just call it bx. Okay. Then I want to solve %o 3 for x. Then I can make my inverse function. So this will give you the time from the velocity. I don't want to use a small v just in case it gets confused, because I've used that as the definition of the function. So I'll use a capital V here and a capital T, keep it unconfused to be safe. And that would be defined as 4 times b minus 216 over 25. So that's the inverse function, and then use that part to determine how long it takes for the car to reach a speed of 150. So that's now the inverse function of speed 150. How much time is that? The answer is, if you want it numeric, about 15.36 seconds. You can actually check the answer. If you type in 25/4 times 15.36 plus 54, you do get 150 feet per second. So the story checks out. You know, I thought I might get all these done today, but I don't think I will. Okay, that's 220. Now on to 221. Okay, an airplane's Mach number m is the ratio of its speed to the speed of sound. When a plane is flying at a constant altitude, then its Mach angle is given by mu equals 2 sine inverse arc sine 1/m. Find the Mach angle to the nearest degree for the following Mach numbers. Okay, so let's get the inverse function first. Y equals 2 times a sine 1/x. And then we want to solve %o1 for x. Then I'll copy this. Then we can make our inverse function, which we'll call it the Mach, not the Mach number, the Mach angle, which is called mu. So I'll just call that function. I'll call it the mu. Where is mu now? Where are you, mu? Alpha, beta, gamma, delta, epsilon, zeta, eta, theta, iota, kappa, lambda, nu, psi, pi, rho, sigma, tau, upsilon, phi, chi, psi, omega, gamma, delta, theta, lambda, z, pi, sigma, psi, omega. No mu. I wonder if mu is a reserved symbol that has a special meaning. Interesting. Okay, mu y defined as paste. Okay, let's change the letters. Okay. Will it be confused by mu? I don't think so. No. Okay. Yeah. So let's try this out. Mu of 1.4, mu of 2.8, and then mu of 4.3. Let's give it a spin. And we can check the answers. Okay, let's see. 221. Oh, I just remembered as I was looking at the answers, it jumped into my head that these are radians and we need the degrees. So what I might do is just change the definition here. Because this is in radians, what I could do to convert it into degrees is multiply by 180 over pi. Now if I run everything again, I should get degrees. Yes, and now I'll have to numeric, and numeric. So 92, 42, 27 does not correspond to the answers. 92, 42, 27. Interesting. I can check. The mistake is perhaps mine. So if I type in their first answer of 92 and I put my calculator in degrees mode, I should get 1 point. Yeah, no, I see. I wonder. I think maybe their answers are wrong. Because if you put in wait, is there no inverse in this question? Oh my, I've been going on autopilot for this question. I didn't realize I didn't actually need to find the inverse this time. Oh man. Okay. I screwed this up big time. Screwed it up big time. Okay. 221. It's just mu the angle m is defined as 2a sine 1 over m. And that will be in radians, so I want in degrees. That was a big screw up. Mu of 1.4. Mu. I think this has to be the last question for today because I'm too tired and I should have caught that. Mu of 2.8. Then mu of 4.3. Okay, give it a run. Then numeric, and numeric. So the answers here is 92, 42, and 27. But I feel like it would have been more accurate for them to say 91 for the first one. But I don't know, you see, because they don't have the double approximate symbol, they have the single approximate symbol. So they might be signaling in the answer that the decimal is truncated rather than rounded. So perhaps that isn't something to worry about. Okay. Yeah, sorry about that. Not ending on a positive, ending on a negative, sadly. So I made this more complicated than I needed to because I was running on autopilot, since all the questions previously required to get the inverse. Not this time. The inverse element in the question was the fact that the function was defined using arcsine, the inverse of sine. So that I guess the author felt that was enough inverted for one question. And in fact, the inverse comes up in 222. So what I was doing a moment ago was more like 222. Yeah. So I think I will leave it there. We'll wrap it up for today. Any problems or mistakes, let me know in the comments. And thanks for watching.